Okay, so this is 3.5 implicit differentiation.
I was gonna do that.
What does implicit mean? Small. Implicit.
Hey Siri,
Sort of implied. What?
hey Siri, what does implicit mean?
Go ahead, try that.
Hey Siri, what does implicit mean?
Obvious, blatant.
It couldn't give you an explanation.
Because I don't know.
It's
Of
blatant.
course.
It's definitely something, guys.
It's like somebody wearing an I love dogs t-shirt asking what animal they like.
Definitely don't.
Cool. Wow.
So we all know that y is a function. of
Is this
x.
3.5?
Yes, 3.5. So we know y is always a function of x, but there are cases where y implicitly will depend on itself. So in the sense, in some way, y ends up being dependent on itself. This shows up in implicit curves and parametric curves. Clearly, in most cases, this is not going to be an actual function by definition. So a good example would be y equals x squared plus xy. Right. So in this case, y depends on y. Of course, I can rearrange this particular expression and come up with y in terms of x alone. Do you agree? So I can move this to the other side. I have a y in common. Divide by 1 minus x on both sides. And I got y as a function of x. So even though when I first wrote it, y implicitly was dependent on y, when I rewrote it, things worked out, and y ended up being a function of x. So easy case, but what if? I have that. Yes. So there, sure, I move that term to the other side, pull the common y out, simplify it, but here, not so much. Because no matter how hard you try, y is going to depend on a function of y. And at the same time, y is a function of x also. So this is what we call an implicit function, because y depends on itself. Does that make sense? In some cases, you can rearrange, end up getting y as a function of x. In other cases, you simply cannot. You just let it be. Why do we need this? We know what inverse trigonometric functions are. Simple one. And sine inverse of x is not equal to 1 over sine of x, because 1 over sine of x is cosecant x. So we can't write it as 1 over sine of x. So y is sine inverse of x, and we want to find the derivative of it. Sure, we may say I could use difference quotients and do a whole bunch of things and come up with an answer. We can't, but it's going to be painful because we have inverse functions. So we are going to do it in a different way. So if I take sine on both sides, Yes, and that's what I'll end up having. And what would happen to the sine and sine inverse? It'll get cancelled. So I would end up having sine y equals x. Y is a function of x, and y sort of got trapped inside sine and it's getting related to x. So y is depending on itself in an implicit manner. I'm going to take the derivative on both sides. We're trying to find dy over dx, correct? But then the right-hand side is fine because it's a function of x, derivative of x with respect to x is 1. So that part's easy. But here, since you have sine y, if you take the derivative with respect to x, you may jump and say, okay, that's 0, end of story. Right, but that can't be 0 because y is a function of x. Do we agree? If y was just a constant, then the derivative with respect to x will be 0. But y is not a constant, y is a function of x. So for a minute, I'm going to, for a moment, I'm going to treat that as x. If I treat that as x, what is the derivative of sine y? Cosine y. But I treated y as x, but in fact, y is a function of x. So there is another step that we've got to do. What is that other step? Derivative of y. Why is that made?
I was saying chain rule.
Chain rule, right? Because y is a function of x. I treated it as x for a minute, took the derivative, and then realized y is a function of x, took the derivative as. Right hand side, as I mentioned, it's just 1, and it's easy. Good.
Wait, so this identity at the very least, like take cosine of y with the whole chain rule is what we want? Are you just saying that?
What?
Sorry, but how exactly did you get 1?
Right hand side, derivative of x is 1.
Oh my god, so you set it equal to, oh.
Yeah, I'm setting it equal to 1. All I did is take the derivative on both sides. Right hand side is straightforward. Derivative of x is 1. Here, I have to use implicit differentiation. The key part is multiplying by dy over dx. That's the most important point. Anytime you take the derivative of y, multiply by y prime. So we have the derivative of y now, well, y is the inverse sine of x. So we found its derivative. So the derivative depends on y in an implicit sense. Do you agree? Y depends on itself. Going back to the first two or the examples that I wrote, the first one, I could do some sort of a trick and express the whatever function that I have in terms of x. So I could do the same thing here. I can write cosine y in terms of sine y. How?
Wait, did you say in terms of sine y? Sine y?
Cosine y in terms of sine y. negative sign, you're not taking the derivative.
Okay.
I just want to rewrite cosine y in terms of time.
We need to use some trigonometric identity.
First, one secant, one minus sine squared y, and there is another thing that we need to talk about. The identity is sine squared y plus cosine squared y. So we move this to the other side, that's what Caitlin did.
However, that still means we need to have a cosine squared y. So we need to take a square root.
So we just have to take the square root. Good. I did all that, but still, y prime depends on y itself. And you may think that's silly, but it's not, because if you go back a few steps, right here, x was sine y. Correct? That's where I started. So I could rewrite
That to be 1 over square root of 1 minus sine squared y is equal to 1.
sine squared y is the same as sine y squared. I know x is sine y, so I can rewrite this as 1 over square root of 1 minus x squared.
How did you get that one? Sine y is.
When I first started the problem, I rewrote everything, and I got x to be sine y. All I did here is, once I got to this step, I'm rewriting sine y as x.
Oh, I see.
Good. So
Okay.
I ended up getting the derivative of y in terms of x. In this case, it was possible, so I got that. So we know the derivative of sine inverse of x is now 1 over square root of 1 minus x squared. Move this. Because if I move there, let's say I can't see. If you follow the same process, set y equals cosine inverse of x, take the derivative on both sides, use the trigonometric identity, a whole bunch of things, you end up getting the derivative of cosine inverse of x to be negative 1 over square root of 1 minus x squared. Good. Now, I want you to use the process of implicit differentiation and find derivative of tangent inverse of x. I'll give you hints. You've got to follow the same process, but with it over here, and you have to use a trigonometric identity, very last step, so that you can express the derivative as a function of x in and of itself. So let's see if we can get it. So we want to find the derivative of tangent inverse of x. So I'm going to start with y equals tangent inverse of x. If I take tangent on both sides. Yep. Tangent y would equal to tangent of tangent inverse of x. Yes. What would happen to tangent and tangent inverse? So at this step, I have tangent y equals x. Good. Moving on. I want to find the derivative, so I'm going to find the derivative on both sides. So on the left-hand side, I will have derivative of tangent y. On the right-hand side, I would have derivative of x with respect to x. So what is the right-hand side?
I mean, one.
1. We know the derivative of tangent. What is the derivative of tangent squared? Secant squared. Y, but y is a function of x. So anytime we had to take the derivative function or function of x, we use the chain rule. So what is the derivative of y with respect to x? dy over dx, yes.
I understand that, but so like you're saying that it's its own entity, like you can divide like, you know, by secant 2y because like dy over dx is its own thing.
Yeah.
But why, what makes it its own thing?
But derivative is its own thing.
So I'm not, I know that's like the symbol, but like you can treat that as like something else such as like x or like a symbol.
Is the entire thing.
Yeah.
Yeah. Call it w. And you solve for w. Right? Because the derivative of y with respect to x is another function. Right? So I can call it plus w. So I want to solve for dy over dx. Which simply is 1 over secant squared y. Now, should you leave the answer as is? I could, we could, but we should always make an attempt at least to see if you can write the derivative only in terms of x. That's the ultimate goal, because if you can express it in terms of x alone, it is easy to manipulate derivatives, it is easy in applications, things will go smoothly. But if y depends on itself, then it's challenging. So I want to change that so that I get x somehow. Right inside is merely a function of x. Even before you go to that step, you may turn around and say, well, 1 over secant y is cosine. I can write the answer as cosine squared y. Correct? Yes? Yes or no?
Yes.
I can, but would that do any good? No, absolutely not. So I want to write it in terms of a tangent because at the beginning I've related x to tangent of y, right? So if I can rewrite secant squared y in terms of tangent y, then I can replace every tangent that I see by x. Do you agree? So dy over dx, we know the identity. One over 1 plus tangent squared y. Going back to the very first step, or second, third step, x is tangent y. So if I replace that, I have the derivative of tangent inverse of x to be 1 over 1 plus x squared, and that is a function of x. Do you get it? Yeah. Purely. You could have left it here, but you should at least try to write it in terms of x, if at all possible. There are cases where no matter how hard you try, you simply cannot write it. Yes.
Why isn't there a square root on it, like over it?
Because of the identity. How is secant squared related to tangent squared? This equals that. Oh, that's the identity. right? If here it turned out to be just secant y, then you have to take this one. Are we clear? So as of now, we know the derivative of sine inverse, cosine inverse, tangent inverse, and key thing to note, derivative of y is not zero. When it comes to implicit differentiation, you always multiply by what?
The derivative from the side.
The derivative of y.
Derivative of y with respect to x, dy over dx, or y prime.
Are we solving all of them?
Huh?
Are we gonna do all the identities?
You can do that. Oh,
I'm just asking.
nope. Recommend you to try it. It will work out. The process is exactly the same. Homework involves you, Gio, not me. And you do it at home. We want to find the derivative of y. Now, you can say that I have a function of y, right? Don't just have y, I have y squared. Typically, in the past, we will have y equals x squared plus x, y equals cosine squared x plus 1. So y was always a function of x. But now there is y, and there is a function of y. And then I've got a bunch of x's, correct? So y will depend on y implicitly. So that is an implicit k. That's actually a third.
I have to ask squared, y squared.
Yeah.
Well,
Well, we have to do some algebra over here.
Actually, let's try that real quick. On the calculator. Well, no, we can't.
So
X's are identical.
I don't have the brain power. That is kind of interesting, you would think, though.
oops. We're going to take the derivative on both sides. We know that we can apply the derivative to each term. Let's start with the right hand side. What is the derivative of 4 with respect to x? 0. What is the derivative of x squared? 2x. Now, since that negative 4 is in product, I'm going to keep it as is. I'm doing this for a reason, so just be patient. Having taken the derivative yet, I just wrote it as this. Derivative of y squared with respect to x. 2y. Is that it?
No, times 1, or times dy dx, right?
We are trying to find the derivative of y with respect to x. We've come this far, we just have to find the derivative of that term. So here is a question.
So why do you have 2y times dy over dx?
Derivative of y squared is 2y, right? But then chain rule multiplied by 2.
Oh, okay, my apologies.
You gotta think about this once.
So don't put that to be 0. If y was a constant, sure, but y is a function of x, so we can't just put 0. So let's say, how do we find product rule? Why? Because they are multiplied and y is not a constant. So if that was to be a constant, I don't need product rule, but x multiplied by function of x, we need product rule.
So this is going to be ultra violence. Oh, no, this is gonna be
Violence.
violence also.
No, I remember them as ultra violence and violence ultra.
What?
Violet.
No, I keep on thinking of doom, so like violence.
U is equal to x, v equals y. U prime, derivative of x is 1. V prime, derivative of y with respect to x,
dy over dx.
dy over dx.
So effectively, you have where u is equal.
Or
to
y
x.
prime, do we agree? Yes. Product rule now, u, v prime,
Y over dx.
plus v, u prime. So the derivative of that xy term is that. Good. I'm going to take this, plug it back in here, try to simplify it and solve. So 2x minus 4 multiplied by the derivative of xy with respect to x, which is x multiplied by dy over dx, plus y plus 2y dy over dx. Good, so far? Yes.
And then
Are we gonna do for like whether dy over dx like cancel or not?
We're not going to cancel it. If it can be cancelled, sure. But what we're going to do is we're going to combine and solve for dy over dx. That's our objective. Can I erase this part?
definitely.
So, one step at a time, so 2x. This will be negative 4, negative 4x dy over dx. Negative 4 times positive y, negative 4y. Plus 2y dy over dx equals 0. Going back to algebra, if we want to solve for a variable and we've got a whole bunch of other terms, what do we do usually? Isolate in the sense we keep the variable that we need on this side and move everything else to the other side. What we need here is dy over dx, because that's what we're trying to find. So I'm going to keep that on this side and move everything else to the other side. So negative 4x dy over dx plus 2y dy over dx equals, move negative 4y to the other side, positive 4y. Positive 2x to the other side, negative 2x. What do I have in common? Over here, 2. What do I have in common over there? Dy over dx, is that it? And 2. This equals 9. I have a 2 on this side, 2 on that side, 2 will get cancelled. We are solving for dy over dx. So dy over dx, divide by this term on both sides. We will have 2y minus x divided by that term. Negative 2x plus y is the same as y minus 2x. We've got this far. You should ask yourself, well, is it worth it to try and rewrite this expression in terms of x alone? No, because if you go back to this expression, even if you try to rewrite it, y would consistently depend on itself time and time again. So don't try. You should only do it if you think things will get simplified. And you may say, this is a lot of work. Who the hell cares? Well, things happen every day. We look at orbits of moon, the sun, the earth. They don't move, as a function of just x alone. If you look at orbits of planets, they're all elliptical, right? And let's say you want to find the rate of change at some corner of that elliptical orbit. You can't simply do it using regular functions. You would rather need a curve, right? So how do we find the instantaneous rate of change of a planet that's moving in an orbit or a satellite that is going around the Earth in a certain way? I find in derivatives of implicit curves, which is why this is important. One thing that I noticed as I went around, you have to take the derivative on both sides. So calculate. When I said take derivative on both sides, I'm simply writing as d over dx, not dy over dx. I don't know why you guys did that, perhaps due to familiarity, I don't know. So d over dx, x e raised y, d over dx, x minus y. Good. Here it is easy, because I have things in addition, subtraction. I can just distribute the derivative. What is the derivative of x with respect to x?
What?
Derivative of y with respect to x, since y is a function of x. I don't know what y is. I'm just going to write it as dy over dx. Good. You can also write it as y prime. It is entirely up to you. I would write it as y prime because it's less work. On this side, we can't take the derivative directly because things are in product. So we have to use product. U is x, v e raised y, u prime is a 1, v prime, I'm going to treat that as x. So if that is the case, what is the derivative of e raised x? E raised x, in this case, y. But then I realized that this is a function of y, so I'm going to multiply by y prime, or dy over dx. Good. This is the same as dy over dx. It's easier to write it as y prime. So going back here, u v prime is x multiplied by e raised y times y prime plus v u prime e raised y times 1. Good. On that side, I simply have 1 minus y prime, or dy over dx. I want to solve for y prime, yes.
Wouldn't the left side be at the very least over e to y?
E to y, what,
E to the power of 2y.
over?
No, under. The denominator would be e to the power of 2y. Because it'd be ey squared.
This is not multiplication, that's addition.
Oh, I know, right, because you were both. I am so sorry.
Okay, so I want to solve for y prime. How do we solve for y prime from that part? Same process, move every single term that's got y prime to one side, everything else to the other side. So I'm going to move y prime to this side. Negative y prime would become positive y prime. Move e raised y from this side to that side, I will have 1 minus e raised y. Good. Now I can solve for y prime. So y prime is in common. If I pull that out, I will have x e raised y plus 1 equals 1 minus e raised y. How do we solve for y prime? Divide by this term on both sides. Y prime is 1 minus e raised y divided by x e raised y plus 1. Should you try and simplify and rewrite in terms of y or x? No.
I was just gonna ask, when it comes to that, when you're looking at rewriting, is it better to leave it the way it is to avoid the mistakes like on the test or something like that, or would you set it up with a certain question that we would have to rewrite it?
Well, if I put a question where you have to rewrite it, it is going to be simple. Because this one, possibly I can't rewrite, right? I can rewrite this part as x minus y over here. Solve for e raised y, write it in terms of x minus y. But I'm not correct. So I wouldn't go past this.
I need to write out. Just so I kind of.